So there will be a little bit more on the re-engineering of the code towards exascale and so on. And Alberto will tell you more about that. This picture is, this figure is part of just transmitting about scaling with number of processors in different kinds of situations. And I'm just flagging it up for as an advance for next speech. But let me mention in this context something which again is close to my heart, which is we are re-engineering codes, and Max is very much at the heart of bringing electronic structure codes towards exascale computing, but we're not doing it in the old way. We're changing paradigm, and this is something that we have been pushing for some time, which is, if you see about this figure on the left, that would be the old way of doing things. You have an electronic structure code, which is monolithic in the sense that the whole code is being delivered as one single unity to be compiled and used, and it is based on relatively very, very basic and fundamental libraries. We're changing to this other new paradigm in which the electronic structure driver is in itself a part of a much more modular entity in which we're dealing with different kinds of things at different levels. Nuclear degrees of freedom would be here in purple, workflow tools, but we have heavy duty electronic structure tasks that are being shared, developed, and re-engineered in a common basis for many different codes, making trying to avoid the reinventing of wheels every step of the way. So that is something which is happening both in the US, in the USA, and Europe. We're both pushing it, and actually in collaboration. Here you have just pictures showing, for instance, here the electronic structure library that has been pushed by CCAM, in which you can see probably codes that you have heard about. Here is SIESTA, but also Abenet, Octopus, FHA AIMS, Quantum Espresso, Big DFT, that have been joining together in order to put together different kinds of, and extracting things, bits of codes that can be librarized, made libraries, and then shared and re-engineered themselves instead of re-engineering the whole code. Same here for the LC effort in the USA about electronic structure solvers. And in this context, let me just finish by mentioning this electronic structure library. It is, of course, bundled, trying to make it easy to use for the community, for people compiling it and so on. But quite a lot of the effort is actually by people that are now in Simune, the company I was talking about before, of which Monica will tell you a little bit more. And with that, I want to finish